I am Radhakrishna, mathematics teacher. Today we are going to continue our topic quadratic equations and expressions. First we will solve some problems. In between we will discuss some theory. The first question, if the equation a square plus b square plus c square into x square plus 2 into ab plus bc plus cd into x plus b square plus c square plus d square is equal to 0 has real roots, then a, b, c, d are in. What is the condition for real roots? Discriminant should be greater than or equal to 0. So, delta is equal to b square minus 4ac means what? Coefficient of x whole square is 4 into ab plus bc plus cd whole square minus 4 into a square plus b square plus c square into b square plus d c square plus d square is greater than or equal to 0. Now, let us cancel 4 on both sides. Then I am going to write this as AB plus BC plus CD whole square. Taking it that side, it is greater than or equal to a square plus b square plus c square into b square plus c square plus d square, right. Now, there is a very famous inequality that is called Cauchy's inequality. The Cauchy's inequality is if A1, A2, A3, B1, B2, B3 are two sets of real numbers, then A1 B1 plus A2 B2 plus A3 B3 whole square means sum of the products of the corresponding numbers in the two sets whole square is always less than or equal to A1 square plus A2 square plus A3 square into B1 square plus B2 square plus B3 square. This is called Cauchy's inequality. This is true for any real numbers. All of you should remember this. Now, suppose these two are equal. Equality occurs when A1 by B1 is equal to A2 by B2 is equal to A3 by B3. This is the statement of Cauchy's inequality. I have written the Cauchy's inequality for two sets of 3 numbers. We can take n numbers in each set and write this inequality. Okay. Now, observe this and this. Here, if you take first set as ABC, second set as BCD, this is same as this, and this is a square plus b square plus c square, sum of the squares of the elements in the first set. This is the sum of the squares of the elements in the first set. By taking first set as ABC, second set as BCD, According to this, it should be less than or equal to, but in the question, since the roots are real, it is greater than or equal to, but greater than is never possible. This can never be greater than that. So the only possibility is equality. Okay, so all of you copy this Cauchy's inequality and remember this. It is very useful in many problems. Now, so this step becomes AB plus BC plus CD whole square should be equal to A square plus B square plus C square into B square plus C square plus D square, because greater than is not possible. Now, what is the condition for equality? If this is equal to this, we get, see, A1 by B1 is equal to A2 by B2 is equal to A3 by B3. That means A by B is equal to B by C is equal to C by D. In 4 numbers A, B, C, D, if the ratio of any two consecutive terms is same, that means B by A is equal to C by B is equal to D by C, then the numbers are in geometric progression. Therefore, A, B, C, D are in GP. So, in the 4 options, correct answer is second option. Actually, in order to explain you this inequality, Cauchy's inequality, I have solved this question in this way, but we can solve it in a more easy way, the same question. If you observe method 2, in this method, if you collect the first terms a square x square plus 2abx plus b square, you can write it as ax plus b whole square. Similarly, if you observe the second terms b square x square plus 2bcx plus c square, we can write it as bx plus c whole square plus bx plus c whole square. And similarly, third term c square x square plus 2cdx plus d square is cx plus d whole square. Is equal to 0. This is the given equation. Sorry, whole square now. Now, if there exists a real value of x satisfying this equation, if x is real, then sum of 3 squares is 0 means each square must be 0, then only it is possible. Otherwise, everyone is positive, so sum should be positive. So if the sum is 0, each term must be 0. If this term is 0, x is equal to how much? Minus b by a. If this term is 0, x is equal to minus c by b. If this term is 0, x is equal to minus d by c. So, if there exists a real value of x satisfying all of them, then what is the condition? These three must be equal. We will get b by a is equal to c by b is equal to d by c. Then a, b, c, d are in GP. This is a shorter method. Okay. Next question. If one root of the equation ax square plus bx plus c is equal to 0 is r times the other, find the quadratic equation whose root is r. In this connection, I want to give you a formula. The formula is, if the roots of ax square plus bx plus c is equal to 0 or in the ratio m is to n, in the ratio m is to n, then the condition is mn b square is equal to ac into m plus n whole square. This is the condition, but how to prove it? Let the roots be mk and nk, because they are in the ratio m is to n, so we can take the roots as mk and nk, so ratio is m is to n. Let mk comma nk be the roots. Proof of this result: if mk and nk are the roots, then what is the sum of the roots? Sum of the roots is mk plus nk. Mk plus nk is m plus n into k, is given by minus b by a, and product of the roots is mk into nk is mn k square. Mn k square is, what is the formula for product of the roots? C by a. Now, if you eliminate k from these two, we will get the condition. Squaring the first equation, we get m plus n whole square into k square is equal to b square by a square. How can you eliminate k now? Dividing this by this. Dividing this by this, m plus n whole square by mn is equal to b square by a square by c by a will be b square by ac. Now, if you cross multiply, you can get mn into b square is equal to ac into m plus n whole square. All of you should remember this as a formula. Now, coming to the present question, one root is r times the other, r times the other. Then the ratio of the roots is what? 1 is to r or r is to 1. The ratio of roots is r is to 1. Then let us apply the formula. Mn b square, what is Mn? M and n are r and 1. Mn b square is r into b square is equal to ac into m plus n whole square means r plus 1 whole square. Now, expand the RHS, ac into r square plus 2r plus 1. Taking all terms one side, ac r square plus here 2ac r, taking b square r that side, you will get plus 2ac minus b square into r plus ac is equal to 0. Now, it is a quadratic equation in R, or we can say that R is a root of the equation R is a root of the equation AC x square plus 2AC minus b square into x plus AC is equal to 0. So, we got the quadratic equation whose root is R. Okay. Let us proceed to next question. Next question is, two polynomials are given, p of x and q of x. What is the minimum number of real roots of the equation p of x into q of x is equal to 0? For real roots, we have to check the discriminant. For p of x, what is the discriminant? Let us take delta 1 as discriminant of p of x. It is b square minus 4ac. And for q of x, delta 2 discriminant is d square plus 4ac. Now, we have to find the minimum number of roots of this real roots of this equation. Actually, this is quadratic equation, this is quadratic equation. So, if p of x into q of x is 0, we will get either p of x is equal to 0 or q of x is equal to 0. So, maximum number of real roots will be 4, okay, but we want minimum number of real roots. Now, suppose AC is positive. If AC is positive, d square is always positive, b square is always positive. If AC is positive, then delta 2 is positive. We can't tell anything about delta 1 because b square minus 4ac, 4ac is positive, b square is positive, the difference we cannot tell. But delta 2 is positive means q of x is equal to 0 will have two real roots. Now, what is the other case? If AC is less than 0, if AC is less than 0, then delta 1 will be positive because minus 4AC will be positive, b square is positive, then delta 1 is positive. If AC is equal to 0, then this is positive, this is positive, delta 1 is greater than 0, delta 2 is greater than 0. So, what can you say? In this case, we can't tell anything about a p of x, but q of x is equal to 0 will have two real roots. In the second case, delta 1 is greater than 0 means p of x is equal to 0 will have two real roots. We can't tell anything about q of x. In the third case, both the equations are having real roots. So, in these two cases, here for AC there are only three possibilities, either it is positive or negative or 0. Therefore, observing all cases, in the first two cases the total equation will have minimum two real roots because at least one of the two equations must have two real roots. In the third case, both the equations have real roots means total number of real roots will be 4. So, what is the minimum number of real roots? Answer is 2. Next question. If A is less than B less than C less than D, then the equation x minus A into x minus C plus lambda into x minus B into x minus D is equal to 0 will have real roots for. Actually, if you want to know about real roots, we have to find the discriminant of this quadratic equation. If you multiply these two, you will get a quadratic. If you multiply these two, you will get another quadratic. Quadratic plus quadratic is another quadratic. So, after expanding completely and writing in the form of a quadratic equation with first x square term, then x term constant, we have to find discriminant and we have to check for what values of lambda discriminant is positive. But that method will be very long. I am going to explain a concept all of you should remember, that is called intermediate value property. Okay. What is intermediate value property? Consider a function y is equal to f of x. You know what is the graph of a function. For different values of x, you will get different values of y. If you join all such points, you will get the graph of the function. Now, if you know that the graph is continuous, means without any break, then suppose the graph is continuous and you have noticed that one point on the graph is below the x-axis, one point on the graph is above the x-axis. And graph is continuous means from minus infinity to plus infinity, it is without any break, it is a continuous curve. So, if a point is here, another point is here, then how can the graph reach from this point to this point? It has to intersect the x-axis in between these 2 points. It may intersect once or more than once. At this point, suppose this is point A, this is point B. At this point, f of A is negative, at this point f of B is positive. So, if f of A is negative, f of B is positive, then the equation f of x is equal to 0, graph intersects the x-axis means at this point y will be 0 now. Y will be 0 means at this point f of x will be 0. So, the equation f of x is equal to 0 will have a root between x is equal to a and x is equal to b. Is it not? It may have one root or more than one root. Similarly, suppose f of a is positive, point is above the x-axis, f of b is negative, point is below the x-axis. Then from a to b, curve has to be continuous. So, graph should be continuous, we have to join this point and this point. So, without intersecting the x-axis, it won't be possible. At the point of intersection, f of x will be 0. Is it not? And this is intermediate value theorem, intermediate value property. So, I will write the statement properly. Let us do it on the next page. Intermediate value property. If f of x is a continuous function, in the interval a to b. Continuous function means from x is equal to a to x is equal to b. Here the function may not be continuous throughout, but if it is continuous between two values of x, a and b, then from x is equal to a to x is equal to b, graph is continuous without any break. And f of a into f of b is less than 0. F of a into f of b is less than 0 means what? F of a and f of b have opposite signs. If f of a is positive, f of b is negative. If f of a is negative, f of b is positive. Then the equation f of x is equal to 0 will have a root in the interval a to b. Okay, here I said a root means maybe one root or more than one root, you have to understand. So, at least one root you can write. Okay. Now, coming to present question. What is the question? Quadratic equation is given, let us write it again here. X minus a into x minus b plus lambda into x minus a into x minus c x minus a into x minus c plus lambda into x minus b into x minus d is equal to 0. This is the quadratic equation. Let us denote this expression by f of x. And a condition is given on A, B, C, D. A is less than B less than C less than D. Let us write that condition. A is less than B less than C less than D. Now, if I substitute f of x is equal to b, because for b lambda will be eliminated because you are getting 0. Substituting b minus b 0, 0 into lambda will be 0. So, I am going to eliminate lambda and get the sign of f of x. So, I have substituted x is equal to b. If I substitute x is equal to a or c, what happens? You will get lambda into a minus b into a minus d. Without knowing the sign of lambda, you cannot tell the sign of f of x. That is why I am substituting b. F of b is equal to what? B minus a into b minus c plus 0. Now, according to this condition, b minus a is positive, b is greater than a, and b minus c is negative because b is less than c. So, positive into negative is negative, f of b is negative. Now, substitute d, because for x is equal to d also this is 0, second term is 0. If we substitute x is equal to d, f of d will be d minus a into d minus c plus 0, second term is 0. Now, what is d minus a? D is the largest of the 4 numbers, so d minus a is positive. Next, d minus c is also positive. So, positive into positive is positive. At b, f of x is negative, at d, f of x is positive. And this is a polynomial function. The graph of a polynomial function will be continuous because it will be continuously defined. You can substitute x continuously from minus infinity to plus infinity. The graph will be whatever is the graph, it will be like this, continuously defined. So, since f of b is negative, f of d is positive, the equation f of x is equal to 0 should have a root between b and d, is it not, according to intermediate value property. That means there is a real root. The equation has a real root. If one root is real, then automatically a second root must be real because all coefficients are positive, real numbers. Here a, b, c, d are real, otherwise order is not defined. A, B, C, D are real, lambda is real, assuming that lambda is real, then all coefficients of this equation are real and one root is real, then the second root cannot be complex because complex roots occur in conjugate pairs. If one root is x plus iy, second root will be x minus iy. That is why for the equation f of x is equal to 0, we will have both the roots real. See how simple it is. to know about the number of real roots. Will have both the roots real for what values of lambda? For any value of lambda, is it not? Both the roots real for all lambda belongs to R. Lambda must be real. So, what is the answer? For all lambda belongs to R, option C is correct. Otherwise, we have to expand and find the discriminant, and we have to manipulate and check for what values of lambda discriminant is positive. Okay. Next question. Let A, B, C be real numbers and A is not equal to 0, alpha is a root of this quadratic equation, beta is a root of this quadratic equation, 0 less than alpha less than beta. Then the equation a square x square plus 2bx plus 2c is equal to 0 will have a root gamma which satisfies. This question is also based on the same intermediate value property. Alpha is a root of the first equation now. So, alpha you can substitute in the first equation, it will be satisfied. A square alpha square plus b alpha plus c is equal to 0. Beta is a root of the second equation. So, substitute beta, a square beta square minus b beta minus c is equal to 0. This is the given condition. Now, this equation has a root gamma. Take that equation as f of x is equal to 0. F of x is equal to a square x square plus 2bcx plus 2c. Consider only expression f of x. You want to know the roots of, you want to know about the roots of f of x is equal to 0. Now, I want to use these conditions. How can I use? Substituting alpha and beta in this. So, I will find out f of alpha. F of alpha is a square alpha square plus 2b alpha plus 2c. Now, I have to use this condition. No? I can write b alpha plus c as minus c square alpha square. So, here a square alpha square plus 2 into b alpha plus c is minus a square alpha square. Then what is this? A square alpha square minus 2a square alpha square is minus a square alpha square, which is clearly negative. Now, I will substitute beta. F of beta is equal to a square beta square plus 2b beta plus 2c. Now, how can I use this condition? From this condition, b beta plus c is equal to a square beta square. I will substitute here. Then I will get a square beta square plus 2 into b beta plus c is a square beta square. So, 2 into a square beta square, then a square beta square plus 2 into a square beta square is 3 a square beta square, which is clearly positive. And it is a quadratic polynomial, graph is continuous. Remember the general points, we can you can understand about everything about continuity of a function and all later, but for the time being you remember that every polynomial function is a continuous curve. Now, this is continuous curve, f of alpha is negative, f of beta is positive. What does it mean? The equation f of x is equal to 0 should have a root between alpha and beta. Therefore, f of x is equal to 0 should have a root between alpha and beta. He said gamma is the root of this equation. So, then the equation will have a root gamma which satisfies. What is the correct option? Oh, sorry, here there is a printing mistake. It should be alpha less than gamma less than beta. Okay. So, correct answer is option D. Okay. Next question. If alpha beta are the roots of x square minus p into x plus 1 minus c is equal to 0, c is not equal to 1, find the value of this expression. First, alpha and beta are the roots of this equation, means I will write alpha plus beta and alpha beta immediately. Alpha plus beta is equal to, what is sum of the roots? Minus of minus p by 1, p by 1, p. Alpha beta is equal to, what is the constant term? P into minus p into 1 minus p minus c, that is minus of p plus c. Okay, now I want to find this value. Now you can observe that numerator is alpha plus 1 whole square. If I want to write denominator also as alpha plus 1 whole square, I have to add 1 and subtract 1. So, alpha plus 1 whole square plus c minus 1, and second term beta plus 1 whole square by, in the denominator I want to add 1 to first two terms so that it becomes perfect square, then I will subtract 1. Beta plus 1 whole square plus c minus 1. Okay. Now what to do? If I add these two, I want to get rid of c. So I will find out c in terms of alpha and beta. How can I find c in terms of alpha and beta? By adding these two, alpha plus beta plus alpha beta is equal to how much? Adding them, minus c. I want c minus 1. For getting c minus 1, what we will do? If you observe, adding 1 on both sides, alpha plus alpha beta plus 1 is equal to 1 minus c. You can factorize this as alpha plus 1 into beta plus 1 is equal to 1 minus c. Now I will substitute there. It is equal to alpha plus 1 whole square by alpha plus 1 whole square. This is c minus 1, no? So we have to take minus of this. Minus of alpha plus 1 into beta plus 1 plus, in the second term also, beta plus 1 whole square upon beta plus 1 whole square minus of alpha plus 1 into beta plus 1. Okay. Now what happens? You can take alpha plus 1 common in the denominator, alpha plus 1 whole square by, if you take alpha plus 1 common, alpha plus 1 into, what is the remaining? Alpha plus 1 will be remaining here, minus beta plus 1 will be remaining here. So, the difference is alpha minus beta, plus, write the numerator as it is. In the denominator, what is common? Beta plus 1 is common. Beta plus 1 into, what is remaining here? 1, beta plus 1 will be remaining here, minus of alpha plus 1 will be remaining here. Beta plus 1 minus of alpha plus 1 is beta minus alpha. Okay. Now, cancel alpha plus 1 from numerator and denominator here, cancel beta plus 1 here. Then, what will you get? I will write in the next page. First term will be alpha plus 1 by alpha minus beta. Plus, second term is cancelling beta plus 1, you will get beta plus 1 by beta minus alpha. Now, I can write this as alpha plus 1 by alpha minus beta minus beta plus 1 by alpha minus beta. Can't I write? Changing plus to minus, I can write alpha minus beta. Now, denominator is same. So, take LCM, alpha minus beta. Numerator will be what? Alpha plus 1 minus of beta plus 1. What is it? Numerator is alpha minus beta, denominator is also alpha minus beta. So, they will cancel, you will get 1. So, the value of this expression is equal to 1, that is the answer. Next question. The value of a for which one root of the equation is twice as large as the other root. If one root is twice the other root, the roots are in the ratio 1:2. So, roots are in the ratio 1:2 means we can apply that formula. What is that formula? mnb square is equal to AC into m plus n whole square. Mn is 1:2, 2. B square means what is B? Coefficient of x, 3a minus 1 whole square. Is equal to AC, this into 2, 2 into a square minus 5a plus 3 into m plus n whole square is 1 plus 2 whole square 9. Now, let us simplify. 2 cancels, expand this, 9a square, 3a minus 1 whole square, 9a square minus 6a plus 1 equals 9a square minus 5a into 9 minus 45a plus 3 into 9, 27. Then 9a square cancels. Take 45a this side, you will get minus 6a plus 45a is how much? 39a is equal to 27 minus 1, 26. Then what is the value of a? 26 by 39. You can cancel the common factor 13. 13 2s are 26, 13 3s are 39. So, the value of a is 2 by 3. Answer is fourth option. Next question. The roots of the equation x minus a into x minus b plus x minus b into x minus c plus x minus c into x minus a are real if Here if A is equal to B is equal to C, what happens? It becomes x minus A whole square plus x minus A whole square plus x minus A whole square, x minus A whole square is equal to 0. So, x is equal to A. Definitely option 2 is correct. But I would like to explain something else. Let us take this function as f of x. Now, let us assume one order like this. If A is greater than B greater than C, some order, that means A, B, C are distinct. Then if I substitute x is equal to A, f of A will be what? A, B, C are real. It should be given A, B, C are real. F of A is equal to, this is 0, this is 0. Putting x is equal to A, you are getting A minus B into A minus C. What is it? A minus B is negative, sorry, A minus B is positive, A is greater than B, no? A minus C is also positive, positive into positive is positive. Now I will substitute x is equal to B. F of B is equal to, what happens? This is 0, this is 0, substituting x is equal to B. Last one is B minus C into B minus A. What can you tell about this? B is greater than C, so B minus C is positive, B minus A is negative. So, positive into negative is negative. Now, you substitute C. F of C is equal to, this is C minus A into C minus B, and this is 0, this is 0. And what is this? C minus A, positive or negative? A is greater than C means C minus A is negative, and B is greater than C, so C minus B is negative. Negative into negative is positive. Okay. And now we know that f of x is second degree polynomial, graph is continuous. Now, A is greater than B greater than C, so take C, B, A like this. F of C is negative means, positive means graph is above the x axis. F of B is negative, so graph point is below the x axis. And f of A is again positive, so graph is above the x axis. So, if you join these points by a smooth curve, definitely the curve must intersect the x axis between C and B once and between B and A once. That means this is a real root, this is a real root. That means if A, B, C are distinct in this order or in this order, this equation will have real roots. But since he said real and equal, answer is 2. Otherwise, for any values of A, B, C, the roots of this equation are real. No need to check the discriminant, just verifying this by intermediate value property. Okay. Next question. See, this question can be asked like this. What is the nature of the roots of this equation? Options real, imaginary, something like that. Then directly, whether A, B, C are distinct or not distinct, in all cases the roots are real. If you check the discriminant, it will be a perfect square. It is always positive, but that method will be lengthy. Next question. Let P and Q be the roots of the quadratic equation x square minus 2x plus a is equal to 0. R and S be the roots of the next quadratic equation. P less than Q less than R less than S are in arithmetic progression AP. Then find A and B, capital A and capital B. So, first let us write immediately the sum of the roots, product of the roots. P and Q are the roots of the first equation. So, P plus Q is equal to what? 2, sum of the roots, and product of the roots PQ is equal to A for the first equation. Now, second equation, R and S are the roots, R plus S is equal to what? 18, and RS is equal to B. Now, they are in AP. P, Q, R, S are in AP. Okay. Now, we can take these terms as let the common difference of the AP be some D. D is, we can take, yes. If the common difference of the AP is D, then Q will be P plus D, R will be P plus 2D, S will be P plus 3D. You know that arithmetic progression will be A plus D, A plus 2D, A plus 3D and so on. So, if the first term is P, common difference is D, second term will be P plus D, third term will be P plus 2D, next term is P plus 3D, because P, Q, R, S are in AP. Now, P plus Q means P plus D, 2P plus D is how much? 2. R plus S, this plus this is 2P plus 5D is equal to 18. We can find P and D by direct subtraction, this minus this. You will get 4D is equal to this minus this 16. D is equal to 4. If you substitute D is equal to 4 in any one of the equations, you will get P is equal to how much? Substitute D here, 2P plus 4 is equal to 2, then P will be minus 1. Then what are the numbers P, Q, R, S? P is minus 1, Q is P plus D, that is what? 3. R is P plus 2D, how much? 7. S is P plus 3D, that will be 11. Then what are A and B? A is equal to PQ, P into Q is minus 3. Capital B is equal to R into S, that is 11 into 7 into 11, 77. Okay. Next question. Same model, but this time the numbers are in, roots are in GP. Alpha, beta are the roots of the first equation, gamma, delta are the roots of the second equation, alpha, beta, gamma, delta are in GP. Then find the integral values of P and Q. As usual, let us take the numbers as alpha, beta, gamma, delta are in GP. We can take the terms of a GP as A, AR, AR square, AR cube. This is the general geometric progression now. If you take alpha as A, beta as AR, gamma as AR square, delta as AR cube, what is the first condition? Sum of the roots of the first equation is alpha plus beta, that is A into 1 plus R. Sum of the first roots of the first equation will be how much? 1. And product of the roots is P is equal to alpha into beta means A square R. Next, similarly for second equation, gamma plus delta, sum of the roots is 4. So, AR square plus AR cube, AR square plus AR cube will be AR square into 1 plus R is 4, and product of the roots is Q. Q is equal to this into this is A square R power 5. Now, how to proceed? By solving these two. How to solve? Just dividing this by this, you will get R square is equal to 4. Dividing this by this, A into R plus 1 cancels. Then R is equal to 2. You can also take minus 2. Now, after getting R, what we will do? Substituting here, you will get A is equal to 1 by 3. If you take R is equal to minus 2, you are getting A is equal to minus 1. Okay, R is equal to plus or minus 2 now. Minus 2, A is equal to minus 1. Now, P is equal to A square R. A square R. A square R is 1 by 9 into minus 2. What is this? A square R. If you take this A square into R, it is not integer. 1 by 9 into 2, it is not integer. But the question is, find the integral values of P and Q, means we have to take A is equal to minus 1. A square into R will be how much? Minus 2. P is minus 2. And what is Q? If you take A is equal to minus 1, A square is 1. 1 into, what is this? Minus 2 whole power 5 is minus 32. So, P and Q are minus 2 and minus 32. Now, similar model, but the method will be slightly different. Let beta 1, beta 3, beta 1, beta 3 are the roots of the first equation. Beta 2, beta 4 are the roots of the second equation. Now, if beta 1, beta 2, beta 3, beta 4 are in harmonic progression, find the integral values of A and B. Here, if A, B, C are in HP, then B is equal to 2AC by A plus C. This we have proved in the previous class. I have explained in the previous class. Now, first you write product of the roots and sum of the roots as usual. What is beta 1 into beta 3? It is, sorry, beta 1 plus beta 3 we will write first. Sum of the roots is beta 1 plus beta 3 is equal to 4 by A. And beta 1, beta 3 is equal to some product of the roots 1 by A, 1 by capital A. Now, for second equation, beta 2, beta 4 are the roots. So, beta 2 plus beta 4 is what? 6 by B. And beta 2, beta 4 product of the roots will be how much? 1 by capital B. Okay. Now, let us take this statement. beta 1, beta 2, beta 3, beta 4 are in HP. If they are in HP, these 3 are in HP, these 3 are in HP separately. Okay. If beta 1, beta 2, beta 3 are in HP, then beta 2 is equal to, according to this formula, 2 beta 1 beta 3 by beta 1 plus beta 3. Is it not? What is it? Substitute here. Numerator is 2 by A, denominator is 4 by A. 2 by A by 4 by A will be 1 by 2. Okay. Similarly, if beta 2, beta 3, beta 4 are in HP, beta 3 is equal to 2 beta 2 beta 4 by beta 2 plus beta 4. Substitute these values. 2 by B by 6 by B, that will be 1 by 3. Beta 2 is a root of the second equation. Beta 3 is a root of the first equation. So, if I substitute beta 3 in the first equation, I will get the value of A. So, substitute beta 3 in the first equation, A into x square means A into 1 by 9, A by 9, minus 4x means 4 into 1 by 3 minus 4 by 3 plus 1 is equal to 0. Then multiplying by 9 minus A minus 12 plus 9 is equal to 0, we will get A is equal to 3. Similarly, beta 2 is a root of the second equation. So, if I substitute in the x is equal to 1 by 2 in the second equation, b into 1 by 2 whole square, b by 4, next minus 6 into 1 by 2 minus 3 plus 1, then you will get beta is equal to b is equal to how much? 8. So, we got the values of A and B. Okay. So, with this the time is up for today. So, this is the end of the class. We are going to continue in the next class with more problems and some more theory. So, before closing the session, I would like to request all of you to refer your friends for the offline program. We want the best students, so that is why we want many students to participate in the admission test, so that our teaching, the top faculty's teaching will be available for only 40 students, special batch, champions batch, for IIT 1 batch and NEET 1 batch, exclusively in Jubilee Hills, Hyderabad. So, please refer your friends